You know what's wild? We've mapped distant galaxies, decoded the human genome, and sent robots to Mars. But there's one thing we've never actually witnessed: the moment a planet is born. Until now. Picture this: 1,300 light-years away, in the depths of space, a cosmic nursery is doing something extraordinary. And for the first time in human history, we're watching it happen in real time. What we're seeing could rewrite everything we thought we knew about how Earth itself came to exist. So here's the thing about planets. We found over 6,000 of them beyond our solar system. We've walked on our moon, sent probes past Pluto, and we've got pretty sophisticated ideas about how all of this formed. But there's a dirty little secret in astronomy. We've been mostly guessing. Sure, our guesses are educated, backed by meteorite analysis and computer simulations, but we've never actually seen the process unfold before our eyes. It's like trying to understand how a tree grows by only looking at seeds and full-grown forests, never catching that crucial moment when a sprout breaks through the soil. The problem is visibility. When stars and planets form, they're wrapped in thick blankets of gas and dust. Our telescopes simply can't penetrate that cosmic fog. It's nature's way of keeping its secrets hidden, at least until recently. Let me walk you through what we think happens. Or rather, what we thought happened. It all begins with massive clouds of dust and gas floating through space, minding their own business. These clouds exist in this delicate dance between thermal pressure pushing outward and gravity pulling inward. They can stay like this for millions of years, perfectly balanced, until something disrupts that peace. Maybe a nearby star explodes in a supernova. Maybe two clouds collide. Whatever the trigger, gravity suddenly gets the upper hand, and everything starts collapsing inward. As the cloud collapses, it spins faster and faster, following the same physics that makes a figure skater spin more rapidly when they pull their arms in. The center gets incredibly hot, reaching temperatures over 1,000 degrees Kelvin. Over about 100,000 years, most of this material concentrates at the center, forming what we call a protostar, essentially a baby star. The leftover material spreads out into a disk, spinning around this stellar embryo like a cosmic record player. Now, here's where it gets interesting for planets. In that spinning disk, tiny particles of dust start bumping into each other. They stick together, growing from microscopic specks into larger grains, then into pebbles, then into rocks. If you're fascinated by the mysteries of space and want to journey through the cosmos with me, hit that subscribe button and turn on notifications. Trust me, you won't want to miss what's coming next. Welcome to Beyond the Stars. Eventually, if enough of these rocks cluster together, they can form planetesimals, essentially the Lego blocks of planets, spanning several kilometers across. Give it enough time and enough collisions, and you've got yourself a planet. But again, this was all theoretical. We'd found young planets before, some just a few million years old, already massive gas giants, bigger than Jupiter. But that still left hundreds of thousands of years of development we'd never observed. We were missing the opening chapters of the story. Enter HOPS-315. This baby star is an absolute game changer. It's less than 150,000 years old, which in cosmic terms is like a newborn still in the delivery room. It's only about 60% the mass of our sun, and it's still feeding, still growing, surrounded by its natal envelope of gas and dust. By all accounts, we should not be able to see anything happening around it. But scientists got lucky. They found a gap in the clouds, a cosmic window, and they pointed the James Webb Space Telescope right through it. What they saw was absolutely mind-blowing. Webb's instruments detected something incredible: warm silicon monoxide gas and tiny crystals of silicate minerals right near the young star. Now, if you're not a chemist, that might not sound exciting, but here's what it means. We were watching gas transform into solid material for the very first time. We were witnessing the literal birth of planetary building blocks. This matters because when protoplanetary disks cool down, different materials crystallize at different temperatures in a specific order. It's called a condensation sequence, and we've inferred what it should look like based on chemistry. and studying ancient asteroids. The oldest solid materials we find in those primordial space rocks are calcium-aluminium inclusions and crystalline silicates. And that's exactly what we're seeing around HOPS-315. Melissa McClure, the lead researcher on this project, put it perfectly when she said this was the first time we'd identified the earliest moment of planet formation around a star other than our sun. Think about that for a second. In all of human history, with all our telescopes and technology, this is a first. But the team didn't stop there. They turned another powerful telescope, ALMA, toward HOPS-315. While Webb showed them the warm inner regions, ALMA could see the colder outer material. Together, these two observatories painted a complete picture of where and how these planetary building blocks were forming. And here's something absolutely fascinating. The region where all this is happening around HOPS-315 is roughly in the same spot where we find similar asteroids in our own solar system. It's like looking at a baby photo of our cosmic neighborhood. The same processes that eventually led to Earth forming were happening there, right now, before our eyes. There's another twist in this story. The researchers noticed something odd. The outflow from HOPS-315 has surprisingly little silicon, way less than expected. At first, that might sound problematic since silicon is crucial for making rocky planets. But Melissa McClure suggested something intriguing. Maybe that silicon is missing because it's already locked up in forming planetesimals. The building blocks are already coming together, which is incredibly fast given how young this system is. This discovery is actually challenging our models. We used to think that gas only started condensing into solids after the star had fully formed and the envelope had mostly cleared away. But HOPS-315 is proving that wrong. Planet formation kicks off way earlier than we thought, while the star is still in its infancy, still hidden behind its cosmic blanket. What does the future hold for HOPS-315? Well, based on what we're seeing and what we understand about condensation sequences, we can make some educated guesses. There's this concept called the snow line in protoplanetary disks. It's the distance from the star where it's cold enough for water and other volatiles to freeze. In our solar system, that line sat at about 2.7 times the Earth-Sun distance. Beyond that snow line, ice accumulates along with dust, eventually forming giant cores that can capture gas and become planets like Jupiter and Saturn. This happens relatively quickly, maybe just 10 million years. Inside the snowline, where it's too hot for ice, only heat-resistant materials like iron, nickel, and rocky silicates survive. These form the smaller, rocky worlds like Earth, Mars, Venus, and Mercury. So HOPS-315 will likely develop a similar architecture, inner rocky worlds and outer gas giants. Whether it'll have an asteroid belt like ours depends partly on whether a massive planet like Jupiter forms. Our asteroid belt exists because Jupiter's gravity prevented that region from coalescing into a full planet, leaving behind a population of rocky remnants. This is our window into understanding how common systems like ours really are. Does planet formation always start at similar distances from the star? How quickly does dust transform into planet-sized objects? These are questions we can finally start answering with real observational data, instead of just models and guesses. Researchers are already planning to search for more systems like HOPS-315, other cosmic nurseries caught in the act of creation. If they find multiple systems showing the same patterns, it'll be like striking gold, a treasure trove of data to help us understand where we came from. It's humbling, really. We're made of star stuff, as Carl Sagan famously said. But more specifically, we're made of dust that swirled around a young star billions of years ago. Dust that somehow clumped together, grew, and eventually became a planet where life could emerge. HOPS-315 is showing us that process in action, offering us a glimpse of our own cosmic origins. This is just the beginning of a new era in astronomy. We're no longer limited to studying planets as finished products, or inferring their formation from ancient rocks. We're watching the assembly process itself, catching the universe in the act of building new worlds. And who knows what we'll discover next? Maybe we'll find that every system forms a little differently. Maybe we'll spot the early stages of life-bearing planets taking shape. If this journey through the cosmos sparked your curiosity, make sure you're subscribed to the channel. We're living in an incredible time for space exploration, and there's so much more to discover together. Hit that like button if you enjoyed this, and let me know in the comments what cosmic mystery you'd like us to explore next. Thanks for watching, and I'll see you in the next one.